Good morning. So today we're going to look at applications to all of our exponentials. So we have two different types of formulas. We have exponential growth. That means that something is going to get bigger over a certain time. Okay, so a quantity increases over time. Okay, so here is our formula. So it's a function of time. We have an initial amount, an initial investment, times 1 plus your growth rate. And that growth rate plus 1 is going to be raised to the time t. So your A is your initial amount. Your R is your growth rate. Okay, your growth rate is going to be in a percent, right? So always make sure to change it to a decimal. And then your time t is in years, or okay. Let's do an example. The original value of an investment is $1,500, and the value increases by 8% each year. Use exponential growth function to find the value of the investment after 20 years. Okay, so each one of these is given to us. So now we've got to figure out what to do. So it's increasing at a rate of 8%. So this is an exponential growth. Okay, so that means I'm going to use this formula. Okay, well, in here my A is going to be my 1,500. My R is 8%. 8% changes to a decimal, so it's going to be 0.08. So that's exactly what we're going to use. And then your T is going to be 20. So here is my function. 1,500 times 1 plus your rate, which is 0.08, raised to the 20th power. So 1,500 times 1.08 raised to the 20th. So when you put this 1.08 raised to the 20th power in your calculator, you're going to get 4.6, 10 basically. And then when you multiply that times 1,500, then you're going to get 6,991.50. So After 20 years, this is going to grow to, instead of $1,500, it's going to be $6,991.50. Okay, y'all do this one for me. Annual sales for a company are $140,000 and are increasing at a rate of 3% per year. Use an exponential function to find the annual sales after 6 years. Okay, so this is going to be a growth, right? So we'll use this formula. So my original investment is going to be $140,000. It's increasing at a rate of 3%. So 3%, but we don't use that. We use 0.03. And then our time here is going to be 6 years. Okay. So our formula is going to be 140,000 times 1 plus 0.03 raised to the 6th power. So in your calculator, do the 1.03 raised to the 6th power first. So it's going to be 1.194. And then multiply that times $140,000. So it's going to be $167,160 after 6 years. Okay? Alright, so that's your growth rate. Well, you can also then have a decay. Maybe something is going to be decreasing over a certain amount of time. So it's not going to get bigger, it's going to get smaller. So it's called exponential decay. So my things and my notation is going to be identical, except for my formula is going to be different. So it's a function of time. So we have our initial amount times your 1 minus your r raised to your time t. So there's a minus in here because this is a decay, because it's going to be decreasing. Okay, so my formula changes. Alright, so all the variables are the same. So A is your initial investment, your R is your rate, and your T is your time in years. So let's look at this problem. The population of a town is decreasing at a rate of 1.5% per year. In 2002, there were 1,600 people. Use an exponential function to find the population in 2008. Okay, so there's a few things that you would have to do here. So your rate is going to be 1,600 people. I'm sorry, your rate is going to be 1.5%. Your initial amount is going to be 1,600 people. Sorry, guys. Okay, so your rate is 1.5%. So remember, we turn this into 0.015. All right, so T is my time in years. So I'm not going to put 2008 in there. My initial year is going to be 2002. So 2008 minus 2002 will give me the years past here. So that's going to be 6 years. This is a decay because it is decreasing. So I will use the 1 minus the rate, raised to the t. So this will be 1600 times 1 minus 0.015 raised to the time in years, which is 6 years. Okay? So the first thing that we're going to do is we're going to find what's in that parentheses right there. So this is going to be 1600 times 0.985 raised to the 6th power. So then we'll say 0.985 raised to the 6th. Sorry. So this will be $1,600, or people, I'm sorry. Then you're going to multiply it times 0.9133. So it's going to decrease to a population size of 1461 over those 6 years. Okay? Alright, y'all do this one for me. An investment of $9,400 loses value at a rate of 2% per year. Use an exponential function to find the value of the investment after 8 years. Okay, so I've got my $9,400, so that's my initial amount is $9,400. It loses value, so loses means that this is going to be decay. Okay, 2% per year, so that's my rate, is going to be 2%. And 2%, remember we changed to a decimal, so 0.02. And then use exponential function to find the value of the investment after 8 years. So my time is going to be 8. So this is a decay, so we're going to say your initial investment, your initial amount is $9,400 times 1 minus 0.02 raised to the 8th power. So we'll say 9,400 times 0.98 raised to the 8th power. So then this is going to be 9,400 times 0.8508, and then you'll multiply that times that 9,400. So it loses money, so this should be smaller than your initial investment, and it is. Okay, so we've talked about growth rate and we've talked about decay. So you should have done this before in Algebra 1. So now we're going to add something else to it. It's something that's called compound interest. All right, so basically how much money you can have in an account over a time frame, but it's going to be compounding interest. So What that means is that if you could put money in a bank account and maybe the interest is compounding every month. So there's a time period that it's going to be compounded. Okay. So compound interest occurs when interest is calculated on both the principal amount and accrued interest. All right. So here's my formula. It's going to be an exponential function. So it's going to change a little bit, but what we do is very similar to our growth and our decay rate here. Okay, so it looks very similar, but something's happening. Right here, this is your N. So your N represents now how many times your interest rate is going to be compounded in a year. Okay, so that really is the only thing different, and it's an N. So number of times interest is compounded. Okay, your P here is your principal. Or what did we learn? What was it beforehand? It's your initial amount. So it's a very similar initial. So it's your starting point, what you initially invest. Your R is your rate, and your rate is a percent, so we change it to decimal. And your T is your time in years. Okay? So the formula, the only thing that you see, what do you see that's different about this? Is you're dividing your rate by your compounding interest, and you're raising all of that to your N power. So that's really the only thing different that we're doing in the formula than we did on our growth and decay rate. Okay, so let's think about what N means. N is how many times something is, how many times compounded. So it's going to tell you that it compounds quarterly. Okay, so if it says quarterly, in a year, what does that mean? How many times is the interest going to be compounded? 4 times per year. If it says semi-annually, that means that it's going to be twice per year. Semi-annually, twice per year. Okay, what if it says monthly? How many months are there in a year? Monthly, there would be 12 months. What about if it said bi-monthly? So that'd be twice per month. And there's 12 months in a year because its N is compounding per year. How many times in a year? So bi-monthly would be 2 times your 12, which would give you 24. If it said weekly, what would that be? There are 52 weeks in a year, so that would be 52 times in 1 year that your interest would be compounded. So we need to know these words right here and what they represent. Quarterly means 4 times a year. Semi-annually means twice. Annually then would be 1. Monthly would be 12 times per year. Bi-monthly would be 24. And weekly would be 52. Alright, so let's do a problem. Jack took out a 6-year loan for $25,000 to purchase a boat at a 4.5% interest rate. If the interest is compounded monthly, what will he have paid over the course of the loan? Okay, so he's taken out a $25,000 loan. So that is my initial investment. So that's my principal of $25,000 to purchase a boat at an interest rate of 4.5%, which we will change that to 0.045. And it's compounded monthly, so monthly means 12. Okay, what will he have paid over the course of the loan? So what is my total payoff, pretty much? We give that money, we're getting that $25,000, but the bank is charging us a 4.5% interest rate. So I'm going to pay more than my loan is worth. All right, so my formula is P times 1 plus your rate over your N, all of this raised to your N times T. So your principal is $25,000. 1 plus your rate, which is 0.045, divided by your 12, and this is going to be 12 times your T. Okay, so this could be a function of time, right? Okay, so when we do this division, first thing that we want to do is 0.045 divided by 12, which is 0.00375. So this is going to be $25,000 times 1.00375, and all of this is going to be raised to the 12 times t. Okay, well 12 times t, what is our t? Our t is time in 6 years. Okay, so I'm just going to plug that in. So you're going to raise that exponent, so you're going to say 12 times your 6, so that's going to be 72. So now you'll multiply, so you'll say 1.00375 raised to the 72nd power. It's a lot. And then you're going to multiply that times 25,000. So calculation is the same, right? So my payoff on my loan is $32,732.58. So $25,000 turns in now to $32,073. $32,732. Sorry. All right, y'all do this one for me. An investment account pays 3.9% interest compounded semi-annually. If $4,000 is invested in this account, what will be the balance after 12 years? So your principal is going to be $4,000. Your rate is 3.9%. We change that 3.9% to 0.039. Your N is now something that's new. It's semi-annually. So semi-annually means 2 times per year. And your time here is going to be over a 12-year period. So we're going to have 4,000 times your 1 plus your rate of 0.039. Your rate is going to be divided by your N, how many times it's compounded, raised to the 2 times your years 12. So this will be $4,000 times 1.0195. Put that in your calculator. So do 0.039 divided by 2, and then add that to 1. And then you're going to raise it to the 24th power. So when you do that, it's going to be $6,358.48. So that amount at that investment rate almost doubled. Okay. I mean, it's definitely, but what did it do? A third, probably. All right, so let's do another one. Y'all do this one for me. All right, so a savings account offers 0.8% interest compounded bi-monthly. If Bob deposited $300 into this account, how much interest will he earn after 10 years? All right, so this is going to be, make sure that you look. I'm looking for how much interest, how much money. So, not my total, but my how much interest. Okay, not total investment. Okay. All right, so your principal is $300. Your rate is 0.8%. We changed that to decimal, so it's going to be 0.008. Your N is how many times it's compounded, and it's bi-monthly. So that means twice per month, and there's 12 months in a year, so 2 times 12, which is a 24. And then your time is 10 years. All right, so the amount in the account is going to be 300 times 1 plus your 0.008 divided by 24, and all of this raised to the 24 times your T10. So this will be 300 times your 1 point, that decimal is almost a repeating decimal, so 0.003, and then 24 times 10, so that's 240. So we're going to raise 1.0003 to the 240th power, and then we're going to multiply it times 300. So when we do that, we're going to get the total amount in the account is going to be $324.98. So this is my total amount. So my interest is going to be $324.98 minus my initial principal. So my interest that I'm going to earn is going to be $24.98. Okay. All right, so that is the end of this unit finally, right? So tomorrow we're just going to review through, and then we'll have our test. If you have any questions, please let me know. Y'all have a good day.